The International Federation of Airworthiness strongly supports the production of these programs. We believe they will lead to an improved understanding of human error management techniques and also to a reduced accident and incident rate due to human errors in maintenance.
Everywhere there are people, there will be human error. Like gravity or bad weather, human fallibility is always with us. In our business, where managing risk is inherent in everything we do, experience shows that human error ruthlessly seeks out weaknesses in individuals and organizations.
Worldwide, it is quite apparent that maintenance errors are on the increase.
Unless we do something about the people problem, dealing with the individual, we will be facing serious problems in the very near future.
In managing aircraft maintenance, we face a simple yet profoundly important choice. Either we manage human error or human error will manage us, always at great cost and sometimes at great danger.
In maintenance, two inescapable realities come together. On the one hand, the potential for error that exists in all of us, and on the other, a huge variety of tasks and conditions which provoke that potential.
Very often, it is the simple human errors that let us down, not those involving technological issues.
Look at the facts globally. Human error in maintenance has been calculated as being responsible for 20 to 30% of in-flight shutdowns, costing an estimated $500,000 each. 50% of flight delays, which can cost in excess of $10,000 per hour in charges and lost business. 50% of flight cancellations, which can often cost more than $50,000 each. And a single disaster can hazard the entire organization. Worldwide, the projected growth in traffic over the next 10 years means that we need to achieve a 33% reduction in the fatal accident rate just to stay where we are in fixed-wing operations. And the helicopter industry generally has accident rates an order higher than the airline industry. And a reduction of 50% is required if we are to make a significant downturn in the rate of fatalities.
Whether it's Asia, Europe, or the United States, the errors tend to be the same, even though people are different in language and culture.
Not convinced? Take just one example. The kind of things which get forgotten despite the existence of long-standing operating procedures. Fastenings left undone, 22%. Pins not removed, 13%. Caps loose and missing, 11%. Spacers and seals missing, 10%. Tools not removed, 10%. Body panels left off, 3%. Miscellaneous emissions, 11%.
Of course, these figures will not be the same everywhere, but the trend is universal.
Despite design standards and practice, which include detailed failure mode assessments, system safety analysis, maintenance review board procedures, airworthiness directives, service bulletins, required operating procedures, and feedback from incidents, such repeated errors continue to occur.
So, what's going on? Why do good organizations with highly skilled, well-motivated staff have the same problems over and over again?
Simple errors can so easily produce the kind of disaster which could, perhaps happen to any of us, like several cases where aircraft have lost lubrication to all engines because seals were left out or blanking plates not refitted properly. More than one aircraft has been lost because an error in maintenance left flight crew without critical performance information. Other aircraft have been subject to emergencies after takeoff because of locking pins left in place following maintenance. Or the helicopter, which crashed because the maintenance manual guidelines for the acceptance of ferrous metal debris from the gearbox was misinterpreted. 520 people were killed following the failure of a misrepaired pressure bulkhead. Of course, such terrible events are rare. We have long established procedures which are intended to prevent, detect, and control the results of human error. Which is why most of us have never been involved in a disaster or even a major incident. Nevertheless, things still go wrong. The question is, why? Our industry is well equipped to understand and detect technical failures, but is less well practiced with human failures, perhaps because they cannot easily be understood in terms of the workplace alone. To get inside the problem, let's explore what human error really is. Slips and trips. When the plan is okay, but things don't go according to it, maybe through distraction or some other discontinuity. Mistakes can happen when circumstances play tricks. Things go according to plan, but the plan is inadequate. Even with the best of intentions, miscommunication can catch out any of us. Sometimes rules are violated when the task in hand seems to demand it, and on other occasions when it doesn't seem to matter very much. Outside work, we all tend to do this kind of thing, so it should be no surprise that these tendencies follow us to work. Because we're human, in any approach to managing error, we ourselves are prone to error. One of the most common of these errors is to see the problem we're trying to fix mainly in terms of the person or team with the most immediate hands-on responsibility. A vitally important part of understanding the kinds of error which can have serious results is the appreciation that when things go wrong, 3 failures will have occurred. The initiating event, usually a single error, sometimes on the hangar floor, perhaps during planning, or right back at the design stage. Error can be built in before the job begins. Next is a failure to detect that error, and the absence of an effective control to recover from the consequences. So human error is not simply a case of the individual getting it wrong, it is a system failure. Most of the time, the system works well, but such apparent success may not be all that it seems. A good safety record is reassuring, but to rely on the absence of accidents as an indication of safety can be dangerous. A cheese shop may seem to be an odd place to find out what happens when things go wrong. But this cheese has a lesson for us.
Would you slice it up for me, please? Maybe 4 or 5 slices long ways?
That's no problem. Thanks very much.
All complex systems have many barriers, safeguards and defenses to separate hazards from victims, from assets and from the environment. In an ideal world, each defense would look like this. It would be solid and intact. But in reality, each defense is like this. It has holes in. And the same is true for all the other defenses. All the defenses have holes in them.
The defenses which an organization managing any kind of hazard must have include good documentation, clear communication, regular training, well thought out operating procedures, effective supervision, and thorough inspection. All are vital to cost-effective operations and the prevention of accidents and unwanted incidents. Day and night, the work we do, whether we realize it or not, is under attack by circumstances and our own inherent tendency to get things wrong. Usually, individual defences hold, and any breaches are frequently neutralised by the skill, experience and goodwill of people in the front line. But just occasionally they are not. Even then, the error is usually neutralised by other layers of defence elsewhere in the system. But sometimes the worst does happen. The one thing that all incidents have in common is a moment when flaws in the system line up for just long enough to allow people and harm to come into close proximity. The absence of accidents may be the result of effective error management. On the other hand, it may simply demonstrate that undetected flaws have not lined up to allow disaster to strike yet. Take just one example, a dropped or dragged engine caused by the fracture of a fuse pin because brace fastenings were not secured. Similar incidents have occurred at least 5 times in different places around the world, among airlines operating from bases with different ethnic and cultural backgrounds. Progressively, defences were breached. In one case at least, the pattern looked like this. Procedures were not complied with. Communications failed. Work cards were not up to the job. Training was inadequate. Visible warnings were not present. Inspection did not pick up the error. What events like this demonstrate is that bad outcomes, just like good outcomes, are a team effort by everyone involved. It comes down to this. Defences are essential, but they are not enough.
We are not alone. The same kinds of errors happen in other industries where people have to maintain and operate complex machinery.
As a percentage of all failures, those attributed to human error look like this. In jet transportation, the estimate is between 65 and 85%. In air traffic control, 90%. In shipping, some 80 to 85%. In the chemical industry, 80 to 90%. In the US nuclear power industry, 70%. And in road transport, 85%. One US airline with a fleet of more than 300 aircraft recorded 203 mishaps due to maintenance errors in a 3-year period. These resulted in 13,299 out-of-service hours. The cost of repairs was $16.5 million. So, in any discussion of human error, very large cost issues are at stake. Managing something as erratic, diverse and whimsical as human error may seem an impossible task. But it's not. Error can be managed systematically and cost-effectively. There are 3 essential facts we must face. The first is that human fallibility is not going to change. Everything we do is vulnerable. Key activities are interdependent. To some degree, everybody must rely on everybody else. Let's review what we do every day in the light of these realities. Each time an aircraft enters the hangar for maintenance or an individual unit is dismantled, there are between hundreds to tens of thousands of related actions, rules, decisions, procedures, statutory requirements, and pieces of communication which must be effectively dealt with to ensure a safe, cost-effective outcome. Making this complexity of people, circumstances, and activity accessible to change is one of the first tasks of error management. Look at it like this. The individual and the task which he or she performs can be seen as being at the center of a circle. Surrounding the individual and the task they undertake is the team of which the individual is a member. The team, in turn, is supported by the organization. And finally, the organization is encompassed by the entire company. In reality, of course, this structure is dynamic. It changes hour by hour on the hangar floor and to other timescales elsewhere in the organization, as people, systems, procedures, and policies change. Because error can happen at any time, anywhere in the organization, it follows that error management must also be at work, everywhere, all the time. And the only way of error management being present everywhere is through the culture of the company, the way we relate to the job and to each other. Later in the series, we shall be looking at the tools of error management area by area. But before such answers can be effective, cultural change as a tool of management must be deployed. Without it, no amount of detailed work will have the desired effect. We must address the prospect of change in the company at large, the organisation which serves it, and among the people who work within it. In the next programme, we explore how this can be achieved.